Hello again, guys. Sorry. Like, first off, maybe just to introduce, like, for the audience knowledge, maybe we do a round of introductions for each one of you and maybe what you guys do. Starting with Kelvin first.
Hi everyone, I'm Kelvin Chen from Google DeepMind. So in recent year, I mainly work on image generation within Google, such as Imagine in earlier times and the recent Nano Banana and Nano Banana Pro. So our team has been focusing on enable different capabilities or different possibilities of image generation models. Yeah, nice to meet you all.
Eugene?
Yeah. Hi, I'm Eugene, CEO and co-founder of Featherless AI. We also so our main thing is we do research into next generation AI architectures. We're talking about 1,000x cheaper inference costs on the RWKV open source project. This AI model has already been deployed on all your Windows laptops on a small scale, over 1.5 billion devices. So it's used to run things in the background, small, highly efficient tasks. We apply these techniques to existing AI models, be over 12,000 AI models, and we are scaling up to 2 million AI models to make open source AI accessible at scale with 10x efficiencies today.
Hi everyone, it's good to be here. I am Sam. I'm a serial venture builder. I built a fintech ventures in 2018 and successfully exited the business 2 years back in 2023. And right now I had the opportunity to work with some of the brightest minds in NTU Lab, which is one of the prominent AI lab in Asia. Some professors over there to build these AI ventures. And this AI ventures is called Ziwei AI. So basically what we are building is we are building a contextual engineering layer that helps the agentic AI as well as the enterprise to improve and also to make it much personalized, kind of like a response. And I think earlier someone mentioned that 95% of the paid pilot failed, right? So I think we are here to fix that problems.
So Stefan, Rozmanowski, AI engineer at Tomoro AI. Tomoro AI are an applied AI company. That means we work with enterprises applying the great technology that is in this field. We position ourselves as the bridge between the model houses and clients and our enterprise clients. Our clients are from a wide variety of industries, from traditional financial services, banks, hedge funds, asset managers, all the way to the left field to sports. We work with a couple of sports leagues, football teams in the UK, as well as marketing. Really, what defines a good client for us is somebody who's ambitious and wants to change their industry with AI.
So maybe I'll start with an open question for all the panelists, because we are actually quite lucky today to have a lot of leading pioneers, specifically within the AI space. So I would say, like, I understand that you guys are working on the frontier, but what is the frontier? Like, what are the things that I would say that excite you, specifically with regards to what's happening with AI research and AI development right now? Maybe anyone? Eugene?
So we'd like to talk a lot about like AI accessibility and things like that, right? So to me, the frontier, there are two major frontiers. One is AI reliability. The best AI models, be it at the closed source lab or even the open source labs, right, can already do orbital physics calculation from Earth to Mars with a 10% chance of getting the math right. How many of us can do that in this room? But the issue is not that they are not capable of doing this impossible task. The problem is I use the word 10% of the time. And essentially what most enterprises want, frankly, is college-level AI that can follow the instructions 100% of the time. And that is the obstacle right now in AI, the biggest obstacle for adoption. And we see lots of companies, be it fine-tuning, reinforcement learning, more and more specialized AI models, not necessarily for it to be a smarter score, but to just get the job done. The other major frontier that we are rather excited as someone from Asia is actually diving down to AI for multiple languages. Because I like to say this, why we work specifically on multilingual. My grandma speaks 7 languages. She doesn't speak English or Chinese. And if we let AI be the way it is, dominantly being written by those be it from English-speaking or Chinese-speaking background, we are excluding half the global economy. But the winds have started to change. More and more countries are starting to get involved in fine-tuning their own AI models for their own language, and that excites me, even though it's still in the earlier stages.
See, that's actually a very good insight, because a lot of the LLMs are from, I mean, the original ones at least, from Llama, right? So when Llama first started, but then when you have your Chinese models like Qwen, like Zipu and Kimi, you know, they obviously come from a different foundational source. At Google, I mean, I'm sure, you know, because I know you spend a lot of time on artwork and stuff, but still, you know, I'm sure there must be some cultural references or cultural influences. How does Google juggle this? You know, like.
I think Google is kind of flexible, because we can't, in terms of frontier, we don't have any very specific goal here. I think it's more like exploring the limits of our model. For example, back in 1 or 2 years ago, we don't know what AI, or even earlier, we don't know what AI can do. We don't even know an LLM can be so powerful back in a few years ago. So I think it's more like curiosity driven. We don't know what could happen with a model, AI model, and that's why many people within Google wants to explore the limit of AI models. For example, in image generation, which is my expertise, our team doesn't know what to do actually, because I mean, many people just think image generation model, just a good image generation model is a model that generates good images. But then it turns out that it isn't. So if we focus too much on the quality of the model itself, then we are kind of bounded in a certain framework. But then at Google, I think it provides us with a very good flexibility. We can freely explore what we want to explore. For example, some people want to incorporate reasoning into image generation model. Some people want to incorporate reliability. And I think it is a very good environment for us to explore different possibility of AI model, which is very important in nowadays, I think.
Okay. How about Stefan, like when you deal with your customers, like, you know, I'm sure people will have like different customization requirements, right? So how do you, you know, make sure that the models you choose are culturally sensitive, right? As well as, you know, like they can work, basically.
Yeah, absolutely, great question. So part of our value proposition is that we build custom, and that means the starting point from a client can be different client to client based on, you know, things like their technology stack, the use case, and fundamentally the problem we're solving. So part of what we do is absolutely assess the correct tools for the job. We are lucky enough that we will work with some brilliant model providers, and I think one thing I've got to say while I'm sharing a stage with him is the Nano Banana model has been fantastic in my personal experimentation. But I think it's a great example of a type of model which I think a new model comes along, new base model comes along, it beats the benchmarks, but I like to think of a benchmark of what capabilities can it unlock. And we actually had a client that we started a project with, we're just finishing now. They challenged us halfway through thinking, we were doing deep reasoning on very technical construction documents, and they challenged us, would we be able to generate, with the current generation of image models, be able to generate these sorts of technical diagrams? And I think we said no, probably not quite there at the moment, but it's amazing to see a model now that is actually genuinely capable of that. But I think ultimately the answer is we work with clients to deliver value with the correct technology stack for the use case. So short term, deliver the solution with the right technology stack, but also thinking about the long term, thinking about the technology, the AI roadmap.
So it really depends on the roadmap of the customer in terms of how you built it. Okay. So actually, For like, in terms of like innovations, you know, because we see the LLM space, you know, rapidly like improving nowadays, you know, beyond just RWKZs, you know, you also have HRM models, you have, what's this, SSM, solid state models, and a whole bunch more, Black Mamba, right, architectures. So, which ones would be your bet? I mean, I'm sure your bet will be on RKW7. So, you know, like, but like, where do you see the LLM space going? You know, maybe I'll start with Eugene first, and then we'll like.
Okay. You're right to point that my current bet is obviously RWKV because the one leading the group, but I will actually
Maybe for the audience, explain what does RWKZ 7 does. Like.
So RWKV is one of the newer AI architectures under the Linux Foundation, where it scales linearly instead of quadratically. And pretty much all the next generation AI architecture is around the idea of linear scaling. This is around the problems that we see with existing AI architecture, where as you talk with it longer and longer over time, larger and larger context length, the cost to do inference scale quadratically, which is a weird property because if I'm a human with that property, for every second I'm alive, my brain requires more and more energy to compute. By the time I'm 10, it will have expanded and exploded. So it's something that is weird about our AI architecture, which all the newer architectures are trying to solve, but we all disagree in how to solve it. So hence all these different architectures in the race. But I think here's an even hotter take on this. I actually believe all of us are wrong because we are not yet at the boundary yet. What we have is in that direction. And I say this for multiple reasons because like I'm recently a father, for example. And we talk about, let's say, scaling data sets to trillions of tokens. But that is, to me, us solving an inefficiency in AI architecture. And the reason why I know this is true, none of us require a trillion token. The human lifespan for 100 years, right, has only 3 billion heartbeats. If one heartbeat is a token, you don't need trillions of tokens. You only needed billions to become intelligent at a university level. Anything more than that is because we have inefficiencies in the architecture. And I'm not saying that we may figure out how to do 1 to 3 billion. Heck, if we even figure out how to make a super intelligent model with 100 billion, that's an achievement. But there's a lot of numbers between 1 to 3 billion and 100 trillion.
Kevin, you're like, what?
Yeah, I don't have a good answer of
We're not giving away like the next Gemini 4.
Yeah, from my personal perspective, I don't have a very good answer of what the future architecture is, but I agree that maybe we are not maybe all the architectures currently are not correct because, as just mentioned, we are not at the boundary. We are still exploring the limit of the models. So maybe in the future, we really do not need a transformer. Maybe we can go back to the basic using an RNN or LSTM. Yeah, but we don't know yet. So I think, I mean, again, I don't have a clear answer, but I think at this stage, we are at the stage of exploring the limit of the AI models. And then after we reach the limit, maybe we can try to explore another more efficient architecture. But yeah, I mean, at this stage, I'm not in the position to describe what a fusion architecture is.
How about Sam?
Yeah, so I think probably I can also share this. At the very beginning, our team did wants to sort of like build this kind of like a LLM model, right? Because I think that is the inefficiency that you just mentioned, just pointed out. Then we found out that, that may not be something that we are able to do that because we do not have the financial muscle to do that, right? So in order to do that, probably you need to invest more money, you need capital, you need probably a big funds, right, in order to do that. So we focus on this contextual engineering layer that we find out that there is a great opportunity for us, right? Eugene pointed out, right, as and when the long contexts have become much longer, when we starts to extend the context, it will become very expensive in this transformer architecture. So that's where we see the opportunity and we grab it. And most important thing is that we are not just able to process like a single modality, but our model, our solutions, we are able to process a multimodality and enable this long context. And as a result of that, we are able to generate the outcome or the response that is much more personalized for the users and for anyone who use our product. So that is the areas that we are focusing on.
The question was on the limitations of the current architectures, right? Yeah, so I guess from an applied perspective, we work with quite often APIs. So we're the builders on top of the foundational models, but of course we get a real sense of their limitations through the sorts of use cases that we apply. I think, there's a lot of the paradigms that people are well used to building on LLMs that we explore, such as, context management, all the sorts of tricks and the sorts of things that you can do to manage the limitations of individual LLMs. But I think really the sort of the position that we take is that we build agentic systems. We're building systems around these models, and I think every time a new model is dropped, of course, we have to reevaluate a set of evals and our starting points all over again. But really, the value that we squeeze out is through the way that we architect the systems that surround these base models.
So I mean, like, do you see a time whereby beyond APIs you will have, because of the speed requirements, right? It's actually far better to even host the models because model size are getting abbreviated, right? They're getting smaller, right? Do you see a time where the models will be being hosted in-house within your clients' platforms?
I mean, absolutely. It's something that we already work with a few clients, clients that have restrictions from a geographical point of view, but also clients maybe more on unfortunately, the ones I can't talk about too much, on the hedge fund side who keep their IP very close. And they are the sorts of clients that have the funds to be able to host these models. But absolutely, I think there is a trend to building systems also with smaller models for different tasks and doing things like for fine tuning in all its guises. But it's absolutely something that we explore, and we've got a bit of a R&D capability built exactly around that at the moment. And actually, it's something that we found. Building in Singapore, sort of the exposure, quite a lot of our engineers have had that already, has been an absolute asset and value add to our company.
Eugene?
Yeah. So to me, the point of us doing research, especially like next generation architecture, is to make it more efficient, to run it at scale more efficiently, even on your own hardware. That was part of the reason why most of our members work on it from the open source group. We wanted to run it on CPUs, we wanted to run it on basically, some of them running on Raspberry Pis even, smaller models. But there is also another way to view it that I like to remind people on, like, our iPhones in our pocket has more compute than the entire Earth had during the Cold War. It's just a matter of time. Like, as the phones itself progress, right, give it a decade or so, right, it has enough compute to run the current best open source model today. And essentially, like what you see at GPT-5 or even like the latest Gemini model will potentially run on your phone in a decade. It's just a time question as technology advances.
It's an entire field called HAI, that what you just described. So I understand, Sam, you guys only work on CPU, right? Not even GPUs. So maybe you'd like to share a little bit more.
Yeah. So we are also quite fortunate that we had the opportunity to get a paid pilot engagement with an Indonesian conglomerate, right? So we are working with their technology team to build this, we call it a small language model on device, on-prem. There are a few considerations why they want to do that, and they do not want to use a cloud solution. So number one is because the videos that they want to process are thousands of videos. can't do it over the cloud because the bandwidth wasn't as great. And another consideration is due to the regulated, right, kind of like an entity as well. So they want to preserve it, and they are a bit afraid, right? If let's say they need to upload everything into the cloud, right, and also use the LLM. So that is one of the areas that they are quite concerned with, and that also gives us the opportunity, right, as a startups to go in and to work with them, to collaborate with them, to build this small language model on their premises itself without the need, right, of their data to leave their servers or their organization.
I see. So, like, for the last, I would say 2021 to 2023, the bottleneck in the past used to be data, but that, now we have synthetic data and everything. What do you think will be the next bottleneck for AI per se, or in terms of development? Maybe start with Kelvin first, like hampering our research towards AGI, basically.
I think one bottleneck would be compute in the short term at least, because everyone wants to scale the model to a very large size. For example, when I was a PhD, I worked on a model with 7 million parameters. But then currently, even the smallest model, open source model, has billion of parameters. Yeah, and I think one bottleneck is, of course, the compute, because PhD students or even small companies, startup companies need enough resources to train the model. And actually, we rely a lot on them to provide insights for us. I mean, for large companies, maybe we rely, some of us are more like an engineer, so we rely many frontier in academia to provide us with new insights, new exploration. But I think a bottleneck would be the compute, because many labs, small-scale labs at least, is unable to get those computes and do some early exploration. And I think it becomes more difficult for them to do exploration, and I think it could be harder for us to develop newer techniques, in the future. Yeah, I think one would be the compute. Yeah.
In agreement, I sometimes like to frame this differently. Access to compute. Because we are in the world's largest build-up of compute, be it NVIDIA, AMD, or whatsoever. It's countless of data centers is being built, not just in Asia, in US, and etc. But access of compute is probably a more important factor, because, frankly speaking, AI had such a big shift, thanks to the big push for transformer, attention all unit paper, all of that. Everything before that paper is kind of not so relevant in the current age, and everything after that, is only a short period of time. And it is very possible for a student who is extremely hungry to study through everything in less than 2 years. But there's a huge catch. How did I do that? And I realized my answer was, I had enough money to just burn on GPUs. I had my own racks of 3090s at that time, and because I managed to get some money through through my own professional life. And when I look at students who are still struggling to just get laptops or even one GPU to play with, that made me think that, hey, the bottleneck when it comes to the research or training them, is really more of no one is willing to pay their $1 million training fee in court burning GPU to learn. And that is a bottleneck when it comes to access. Not necessarily mean compute is not there.
Sam?
Well, I think at the end of the day, what we can also expect is that the compute and also the cost will continue to come down, right? So when the cost comes down, I think in this in where we are right now, we are also quite fortunate in the sense that when we try to build all these ventures, we do get a lot of supports from all these like a startup program, for example. So in a way, we can get all these like a compute for free, right? At least at the beginning, and we try to validate, we try to test the ideas, and the ideas stick and validated successfully. We come up with a business case that is strong enough, right? Then we can gain the tractions, right? Then at the same time, the compute, the CPU or the GPU power would probably the cost will continue to goes down, right? So I think that is quite conducive environments for all the startups to build our business venture.
I think I'll take this slightly different direction, maybe from experience of an applied AI company, but for us, our current bottleneck or an expected bottleneck could be evals. Where the industry was 2 years ago, everybody was making POCs. Hopefully, a few more than 5% of them are still in action, but yeah, there or thereabouts. But these days, people are a bit more serious with that, and they found those use cases that are providing value. Now, in order to build a robust system, we as Tomoro, and I think a lot of the builders in the industry, rely heavily on evals. So the availability of quality evals and the maintenance of those as you have more and more systems in production I think you could almost look at follow the job titles, right? One of the first new job titles in this era of AI was prompt engineer. And then I think I heard of a context engineer recently, and I think the newest one to me is an evals engineer. So yeah, I think that's my answer for the bottleneck.
Like for safety, like evaluating the safety of the model.
A eval can absolutely be positioned to be the safety of the model, but really it's the ongoing quality of the model. You build a set of evals when you're setting out to build an application, an LLM-powered application, and the alignment of those evals to the business outcome is critical. That's how you connect the two. That's how you connect the technology, the language model to the success factor. But a year on, the business changes. Data drift was a machine learning concept, which is still relevant in this in the age of AI. But it's exactly the maintenance of those. I think there's going to be there already is a need for ongoing data collection and data.
Tomoro also has a framework that you develop in-house, right? Specifically on how to evaluate the success of the models. Maybe you would like to share about that to our audience? Yeah.
So the question about our evals approach in-house. Yes, we've got a number of assets that when you buy our consulting services, you get for free a number of our in-house assets, such as our evals hub. And it's a set of methodologies and based on the open source and open source data sets. But really it comes with it. It's a part of our delivery model. As standard, we do deliver production grade solutions underpinned by evals. It's a term that I'm on a personal mission to coin is evals driven development, sort of inspired by test driven development, software development. I think the eval comes first, then the solution comes second.
So with regards to like, in your, this is again directed to both Kelvin and Eugene, more towards both of you. What's the one truth that you realize, as you do your research and trying to push the AI boundaries further, like, when you're doing this, what's like the aha moment? This is this is actually what I'm doing. Maybe start with Eugene first.
I slightly alluded with my story of my grandma. So fun fact is I'm horrible in Chinese. She doesn't speak English or Chinese. So I always found communicating with her extremely difficult. And because my family came from Malaysia, some of them have roots in Indonesia and things like that. As I look into it, like for example, hey, I have family members who are not even making 800 USD a month. I have family members who are working in banks in Malaysia and things like that. And to me, why I work so heavily into open source AI, into multilingual AI, is ultimately about democratizing access to AI to everyone. The team's goal is regardless of language, nation, or compute. Because what I find scarier is that if you take for Singapore, for example, oil, we got our 3 pillars: oil, trade, and services. Oil, we are decarbonizing, we are going green. Trade, very dependent between US and China, that has its own set of problems right now, put that aside. And then finally services, very vulnerable to be replaced by AI. If we are all 3 being decimated at the same time, we are in an existential crisis situation for the country, whether we realize it or not. And I don't have the answer for how all of us will get out of it, but I want to make sure that all of us have AI as a tool to figure out a solution that speaks our language. So for Singapore, it's easy. We are just going to use the English AI. But what about my relatives in Malaysia and Indonesia? They can't use those AI models. And then subsequently, can they afford the $200 a month AI models? They can't. So that's why I walked into this. And I was like, I really need to get this to work because there'll be people who will need it.
Kelvin?
My reason is actually a bit simpler. It's just I think working in AI gives me the sense of unknown because I don't know what we can do with AI, and then I'm curious about what we can do. For example, my undergrad and master was in mathematics. So, and then back in my times, I do not know a lot of AI, and then I work in applied mathematics, use mathematics to do some image processing. And then at some point, I started to know AI for image generation and editing. And then I realized that there is a completely new field that I can explore that I don't know what to do, but then I know that it can be very powerful. And then at that time, I started working on AI, and then I found that, okay, this is fun. And then, yeah, I can explore different things, for example, generation, editing, and also language model, different things. And we can different possibilities with it. And then I feel like I can learn a lot from this. And I just feel, yeah, I'm happy with this. And yeah, I don't have any very good reasons for that, but I'm more like, I'm curious. I want to know what happened. I want to be a part of the success in the future. So that's why I entered this field. I keep working in this field, and hopefully I'll be continue working in this field in the future.
So just for the audience, for those who don't really understand the architecture, so for what InGen does, and again, correct me if I'm wrong, it's more diffusion. So diffusion and LLMs are actually slightly different architecture. Diffusion is just to go from noise to signal back to noise, right? And LLMs is through a matrix or multiplications. So and because of that, if let's say if you are if we have, I'm sure we have some students in the audience. If someone wants to learn about AI, right? I mean, like really learn, not like using ChatGPT, right? That like where should one start, right? Like, and I personally believe that anybody can start learning about AI. For me, it was YouTube videos. Then I started, looking at scholar articles, and then actually doing my own LoRa's for diffusion. So if you were to give advice to someone who wants to, learn how to, architecturally or structurally how to build the model.
Yeah, when I started learning deep learning, I just watched YouTube videos. There is a Stanford course, I think many of you know that. I watched that, and then I learned the basics of deep learning. And then I think the next step would be choosing one interesting topic. For example, if you are interested in language models, then you try to find some papers on language model. Or if you are interested in diffusion model image editing, then you find some papers. Then after you read enough papers, you'll get a rough sense of how this field is working, and then you know if you read enough paper, you know that, okay, there is something maybe this unsolved in this field, and I can try to tackle this. And then nowadays, I think it is really good that you have a lot of tools. For example, if you have some questions in the paper before, in the past, you need to go through Google search. You need to search every single details to understand the paper. But then now you have Notebook LM, or also you have ChatGPT, Gemini, so you can interact with the model. And then if you have any question, you can just ask the model, and then to interact with it to understand the paper. So I think nowadays, the first step is to start doing this. For example, watch YouTube videos and then find some topics that you feel interested in.
Any YouTube videos that you recommend, like channels for our audience?
I forgot that one is called CS231.
It's about the Stanford CS course too.
Yeah, because I'm interested in images back in that time, so I watched the computer vision. I forgot the exact one, but it's more about computer vision using deep learning. So I started with that one, and then I started reading papers, and then learn more, and then up to now.
Just for our audience, diffusion models came out of Stanford. So, the first diffusion model came out. So,
going to be a lot more very specific, because assuming that you know programming, some basic programming, the YouTube videos you want to find is Jeremy Howard's Fast AI and an introduction to AI, Andrew Karpathy. Those two major series that will pretty much cover you 80.
You mean the 3.5 hours, the one that he did? Andrew Karpathy, the 3.5 hours video that he did.
Oh, he has a lot 3.5 hours video. Jeremy Howard's has an entire series on Fast AI, and the reason why I point to these two is Jeremy Howard's been doing this kind of content and been doing it for free before the ChatGPT cycle. His goal was just to democratize the access to this kind of knowledge. He covers it quite in depth, and Andrew Karpathy covers more of the more updated recent stuff. And he's been constantly updating his materials as well. These two will get you to quite far. You will then need to get a GPU. Maybe secondhand 3090 is probably one of the best thing you can get for a student. And then after that, if you really do not know programming, like what I mentioned, when it comes to AI specifically, or asking questions about existing AI architectures, the current closed source models, all of them are really good at it, because it's clearly internally there is some the term is dog feeding that's happening within the team, where they get the model to ask questions and then they use it themselves. It's shockingly good how much the models understand all this architecture stuff compared to any other domains.
Sam?
Right, so you can learn from my co-founder, NTU AI professor. It's helping him to gain more business right over here. But anyway, jokes aside, he has given me a list of material to read through, right? So if you're interested, then after this, you can come to me, then probably I can share the list with you as well.
Just an insight, his co-founder won this year's Young Scientist Award for text to 3D images, right? So he actually helped to pioneer a modality within the AI. Stefan?
I think I owe my career to platforms like Coursera and DataCamp, etc. There's so much, there was before the age of AI, so much of amazing material available for free on the web. But honestly, I've advised so many friends, family, colleagues recently that the only place you need to start is with an LLM. Take your LLM of choice and ask it to create a curriculum with you. Use that as your index, explore, read, explore different modalities. People are different learners, different styles. One thing I love is Notebook LM. I'm a runner. If I have a paper that I want to understand, I generate or ask a Notebook LM to generate a podcast for me, and then I can learn when I'm running. So we're very lucky to live in this age where information is so accessible, and now it's so accessible to people who are of different learning styles.
Okay. Because we have time, we're going to leave a couple of questions to the floor. Anyone has any questions? Do I see anyone? Sorry. Okay, my last question. Okay, what is your wish for where the development for AI would go? Like, what is your what do you hope that AI, like for example, no, now we have text to 3D. Then next we have text to task, or task to text. Like what would be your wish for AI development to go maybe in the next year or so? That would be my last question for today. That's not related to your work, of course. So like,
Much longer time horizon. I want AI to be extremely personalized. And so think of it as like, we probably seen like science fiction like Wall-E, Jetsons, and things like that, where basically the family have their own AI robot and stuff like that. We probably have seen some cartoons or animations where the kids are playing around with their own AI robots, things like that. And they can become friends, useful advisors, teachers, and things like that. That is something that I wish to see that we are able to reach, an AI that a parent can literally trust to play along with their kid, to guide the kid into being someone better and to learn and be a friend that goes through their entire life. And I don't think we are there yet, but that's what I want to see.
Kelvin?
Yeah, I share a similar vision. I hope that in the future, AI models will not replace human, will be a partner to human. For example, there will be some tools to save your time, just like what I talked before. It can help you prepare some slides so that you can focus on your ideas. You don't need to spend time on polishing your slides, something like this. And also doing some research. For example, nowadays the language model can help you save some time to do research, so you can focus creativity or innovation. So I hope that in the future there will be a partner, they will work together instead of AI will replace human. I think people always hear something about this, but I hope in the future they will coexist and they will create a very peace and peaceful environment that we can work together.
Yeah.
Yeah, so for me, it's more like autonomous AI. So the AI can do all the hard work and also help mankind or humans to generate revenue, right, or generate income, so that it can help us to reduce most of the work. But I think one thing for sure is that while they can be our good buddy, good partners in brainstorming things, but humans should not stop to think and also should not stop to learn.
Stefan?
I think this might be a bit of a scary one, but I think AI-assisted, or AI personal assistants, AI run coaches, there are so many autonomous AIs that are deployed, but the one problem or the one difference they have between AI and a human is an accountability that we hold ourselves to the AI. I can always just switch it off. I can ignore ChatGPT. And maybe it's a bit of a scary concept thinking about what that would look like, but if my AI run coach, if I'm scared to miss a run tomorrow, I think that will be a good outcome for my running performance.
Okay. I think we'll end like 2 minutes. We have 2 minutes to go. You sure nobody has any questions? Okay, cool. Just shout it out.
I would argue no.
Can I answer this question? So because I'm a venture capitalist, so I actually get this a lot. So, it's a great question. I don't think people always like to quote Colonel Sanders, right? So he started at 60, right? I would say no. The short answer is no, because there isn't a one format to actually form companies. Companies that actually do enterprise software, actually successful companies usually have about age of 45 and above, right? Compared to young. I did an enterprise startup in my youth, and it was a horrible experience. Yeah, because I didn't have the know-how or the maturity, right? So, which is why we pivoted to SaaS, and we did well in SaaS because it was prosumer, right? So, but yeah, I just wanted to address that issue. There should not be an age limit. Actually, the older you are, the better when it comes to enterprise applications. Yeah. Sorry.
I said no, mostly because the advantage of youth is you got lots of energy. The advantage of slightly older, you get more experience and connections. And basically, if you depending on what kind of startup you have, it can actually strongly favor one over the other. Sure, if you're doing a TikTok social media thing, yeah, the youth will probably win me. but if you're doing something that is, like you said, very B2B, very industrial, domain knowledge is going to be a very strong factor, especially now more than ever, because the technical parts, let's say you want to do a B2B AI assistant for medical. Your domain knowledge as a doctor will probably be the most important thing, because the application layer can be done by pretty much by any technical person plus AI. That part will be more and more commoditized, and your domain expertise will become more important.
Anyone else has?
Fully agreed, except the TikTok part. I think regardless of your age, you can still become a TikToker.
Actually, on this note, the average age of he's right. The average age of TikTok, if you look at the top Singapore streamers, right? Actually, there's a large segment is 40 and above. Like Uncle Raymond, remember? Like the guy does that. Yeah. So strangely enough, because TikTok actually has a older population of people reading, So it's not without cause. So, anyone else has any questions? Because it's very rare that we have all these like AI, like luminaries, right, in this space, right? I can't even imagine how, like the, yes. Oh, yes, at the back. Just shout it out. Wait, Marina. Oh, this is Daniel.
Hello. Just targeted to Eugene for your opinion. Coming from Malaysia, I think what are the advice would you actually give for Malaysians actually in competing in this AI space at the moment?
Tell him, don't tell.
I actually had similar questions to from some of my investors, even from Philippines and all that. Tapped into existing industries, domain expertise, and digitize them with AI. Like, for example, I was talking to a few Philippines companies that are right now call centers. And if you don't know, the call centers were all utterly heavily decimated with AI. And it's like, before you lose all your customers, you have to deploy AI. So take that same approach. Where is your strength right now? How do you apply it right now? That's one thing that no other country can do. So if let's say you have strength right now in petrochemical part when it comes to petroleum, Petronas, for example, Singapore's not going to compete with Petronas. So yeah, take where your strength where it is.
Any more questions? Oh, Miranda.
Thank you. My name is Miranda. I have a question regarding physical AI, because recently I read a statement from Dr. Feifei Li. She mentioned about the next wave of AI is really about physical AI. So I really want to hear your opinion about that. Thank you.
Yeah.
Well, until the AI actually fixed my plumbing issue, which I haven't fixed the dishwasher in my house for a very long time, that is physical AI in the sense. Like, there is a huge boundary in steps. Like, right now, most of the language models are not even designed for interacting with the physical world. For example, Feifei Li World Lab is trying to build the world models to be able to simulate the physical world so that we can train AIs to actually interact in those physical worlds. That is a long way to come, and I look forward to it.
Maybe I'll take a stab at the question. So, Prof. Li Fei, I mean, she did ImageNet, right? So, I mean, we won't have diffusion models without ImageNet because it was. So, I think she needs to do something to get to the physics. It's like you need an ImageNet to get to your ImGen or your diffusion model, stable diffusion, right? So, but we will need to collect enough physical information or pool source the physical information before we can get physical AI. So she needs to start something else before we can get, somebody needs to collect enough relevant information and invent a feasible architecture before we can get there. Yeah.
Pretty much all the major themes is the next big bet. After the current AI race, the next big bet is physical AI. Even if you look at NVIDIA share report holdings, it's the next big bet.
Yeah, but something needs to happen. I'm not sure what. Yeah. Thank you. I think we're out of time. So thank you, my dear panelists, for a very long and rigorous panel, and thank you everyone for staying so long. Okay.